Hi everyone, today I'm going to talk about some basic statistics, specifically descriptive stats. So a descriptive statistic is just anything that describes the data set. So any kind of measure, any sort of number or quantity we can use to describe data. So we're not trying to estimate anything, which is what we would do with an inferential statistic, but we're just going to use things to sort of summarize the data essentially. So we're going to make up a data set, and we're going to use just the absolute value of these normal draws, and I'm doing that just so we don't get any negative numbers. So say this is like parts per million pollution data for, say you have like a sensor at a weather station, something like that. So we run this, actually let's clear that first, and we run this, and we just have some pollution data. So we can do that here, and it just a bunch of random numbers and say these are readings on a sensor. So we can run this, and we see here the frequency of this. So that's kind of the first descriptive statistic we would use to describe how things are distributed. So pretty straightforward, and we can set here like more breaks, so it just shows it at a more fine grain level, and we can see a little bit more in detail how many we have in each of these bins. So we can calculate the mean here and just use the R function it's just mean. So it's the arithmetic mean, so you sum up all of the data points and then divide by the number of points that you're trying to average. And you'll also hear it just called average. But the problem is, if say we observe a huge outlier, so we're just going to add 10,000 to this, the mean can be pulled, we say. So you see here, this is a huge difference between this. So, but most of the numbers haven't changed, it's just that we have this number at the very upper end. So to handle that, we have something called the median. So the median is not affected by outliers. Not in the same way. So if we add another data point like we did here, the median might change just because of the extra data point, but it's not average, so it's just the middle value. And same thing here, we just run this and we see this is much closer to the original mean, and we're doing this on the data set with pollution, or the outlier, so we see that it's much less affected. The mode is another common descriptive statistic, but there's not a sort of base function to calculate the mode, so I just have this little function here, but all this is doing is just finding the most common value in a data set. So if we run this, we'll see that it returns 1, which is the most common in this little vector we have. And sometimes you get what we call multimodal data, so if it has multiple peaks. So like we look here, and we kind of don't really see any here, but maybe here we do. So it's kind of, if you imagine a line, it's like you have these sort of 2 peaks, so that could be considered multimodal. And variability kind of goes hand in hand with these measures of the center of a distribution. So variance is usually always where you start. So it's always a positive number, and we denote this with the normal distribution as sigma squared, but sometimes you'll just see it written as like VAR. So all we do here is just call this just a built-in function in R, and that describes the spread of our data. And standard deviation is maybe what you've heard more of, but it's also a measure of spread, and it's just the square root of variance. So we just denote this as sigma, and we use this function SD. And we see this is our standard deviation. And just mathematically, we know this is sigma squared is the square root, or we take this square root and we just get sigma. So that's the standard deviation. So we can double check that this is going to work. So we take the square root of the variance of pollution, and we get the same number. So we confirm that that works. And then sometimes you see the range as well. So the range is just the minimum and the maximum values of your distribution. So sometimes maybe the center of it is kind of somewhere. You guess that with a mean, or you calculate that with a mean, and then you may want to to know, okay, but how spread out are these? So the home prices in a neighborhood, for example, you may want to know, okay, you have a mean of $75,000, but is the range, 10 to 150, or is the mean 10 to 1.5 million? So we just use the range function here, and this returns two values. So we see this is the minimum, and this is the maximum.